Section 5.2 is titled Solving Equations with Variables on Both Sides. So what we first want to do is look at the rules for solving equations with variables on both sides, and I would like you to write all of this down. So the first thing we need to do is simplify on both sides, and remember when we're referring to sides, we're talking about the left side and the right side of the equal sign. We want to distribute if we need to, we want to clear fractions if there are any, and we want to add like terms if we see any. Then what we want to do is move all of the variables to one side of the equal sign. And variables move in equations just like constants do. If it's a positive 5x, then we want to subtract 5x. The third step is to move all the constants to the opposite side, or to the other side of the equal sign. So if we move the variables to the left, we want the constants to move to the right, and vice versa. Then finally, we want to get the variable alone by doing any multiplying or dividing away of the coefficient. And we're only going to look at a few examples here because I think once you see a couple, you'll get the hang of it, and then we'll be able to practice in class. So we want to solve each equation. We have 7y plus 8 equals 4y minus 10. And one of the steps says after we do any distributing or combining like terms, which there's nothing to distribute and there are no like terms to combine, we need to move the variables to the same side. Notice we have 7y on the left and 4y on the right. What I like to do is move the smaller variable over to the side that has the larger variable. And what you're doing here is you're comparing coefficients. So 7 is larger than 4, so I'm going to move the 4y. The question is, how do I move it over there? Well, it's a positive 4y, so I'm going to subtract 4y to the other side. And you'll notice that I write it right underneath the y because that's the term I have to combine it with. I can't combine the 4y with the 8 because the 8 doesn't have a variable. So those are going to cancel. Now I need to look at what I have on the left. 7y minus 4y is 3y. I still have the plus 8, and it equals negative 10. Now this equation looks exactly like a two-step equation that we worked on earlier. So we're going to subtract 8 from both sides. That's going to give us 3y equals negative 18. And now we divide both sides by 3, and we get that y equals negative 6. And we can check our solution. There are some of your homework problems where I'm going to have you check your solution, so I'm going to show you how to do that here. Here's how to do a check. Just like before, you're going to plug that answer in for the y, but notice there are two y's in that original equation, so we have to plug it into both places. So 7 times negative 6 plus 8 equals 4 times negative 6 minus 10. And then you need to simplify both sides. We want to make sure that the left side equals the right side. So here we get negative 42 plus 8 equals negative 24 minus 10. Well, negative 42 plus 8 is a negative 34. And negative 24 minus 10, remember you can add the opposite, is a negative 34. So we see that the left side equals the right side. Our solution checks out. Let's look at another example. We have 2x plus 3 equals 3x minus 2. There's nothing to distribute, and we don't have any like terms on either side to combine, so we simply need to start by moving the variable. So the first question I'm going to ask is, which variable are you going to move, the 2x or the 3x? And hopefully you're saying the 2x because it's smaller. It's a positive 2x, so we're going to subtract it to the other side. And again, notice how I'm writing it right underneath the 3x term. Those terms cancel, and I'm left with a 3 on the left. I bring down my equal sign. 3x minus 2x, so I just do 3 minus 2, which is 1, or just x, and I bring down the minus 2 in the back. Now we're solving for x, so we're going to add the 2 to the other side. Remember, we always do the opposite of what we see. So 3 plus 2 is 5, and I get 5 equals x, or x equals 5. Those are both the same answer. And again, I want to show you a check. If we check our solution, we need to plug that 5 in where we see both of the x's in the original equation. So 2 times 5 plus 3, and 3 times 5 minus 2. So we get 10 plus 3 on the left, we get 15 minus 2 on the right, and we get 13 equals 13. That checks out. We know that our answer, x equals 5, is correct. And this is the last example, so what I'd like you to do is try this one on your own. Try to get the variable on one side, get the constants on the other, and then solve the equation. So please pause the video, and then you can hit play once you've gotten an answer, and you can check your work with what I've done. So we have 5p plus 15 equals p minus 49. Remember that this p does have a 1 in front of it, so which one has the smaller coefficient? This one does. So we're going to subtract p from both sides. And you don't have to write that 1 in there, I just did that so that you remember there is a 1 there. So if we have a positive p or a 1p and we subtract 1p, those are going to cancel. That's why we do that. So on the other side we have 5p minus p. So essentially you have 5 p's and you're taking 1 away. So you have 4 p's plus 15 equals negative 49. Now again, we're back to a two-step equation, so we subtract the 15 first. Remember, we do PEMDAS in reverse order. So we have 4p equals, and we have a negative 49, and we're subtracting 15. So that should be a negative 64. Now we need to divide both sides by 4. We have a negative divided by a positive, so we know that our answer should be negative. And if you're not sure 64 divided by 4, you can use a calculator or you can do it longhand, but our answer will be a negative 16. And again, let's show one more check because you will have to do some checks on your worksheet. We're plugging that negative 16 in for both p's. So we get 5 times negative 16 plus 15 and negative 16 minus 49. Notice I've plugged the negative 16 in where I see p both places. So 5 times negative 16 is negative 80 plus 15. And we have negative 16 minus 49. You could simplify that there. I just brought that down one more step. So negative 80 plus 15 is negative 65. And negative 16 minus 49 is also negative 65. So you can see that your solution checks out. In class, we'll work on worksheet 5.2.